Let's look at the parts of a seesaw. There are only two parts to a seesaw, a lever and a pivot.
Seesaw, up and down, you go up and I go down.
Are you sure you can go up and down if I'm on a seesaw with you?
Well, you will need to sit nearer to the triangle thingy in the middle.
You mean the pivot?
Yes, the thing which is stuck to the lever and the ground. The pivot.
Okay, let's see.
I never understood why the lighter person should sit further back, while the heavier person should sit nearer to the pivot.
I think what you mean to say is that the weight of a heavier person might be balanced by the weight of a lighter person, so long as the lighter person sits further from the pivot, while the heavier person sits nearer to the pivot.
Yes, that's what I meant.
And you remember that it's easier and faster to bring the seesaw down to the ground when you are seated nearer to the edge as compared to when you are seated nearer to the pivot, right?
Yes, I remember.
And you remember that weight is a force, right?
Yes, weight is a special type of force and can be calculated by this equation. Weight is equal to mass times gravitational acceleration. Since my mass is the same and the gravitational acceleration is the same, the weight exerted on the seesaw on my side should be the same, whether I sit at one end or near the pivot. Since force is the same, then why should the seesaw move so differently?
That's because the pivot causes the seesaw to rotate or turn rather than move in a straight line. Let's look here. As you can see here, when Joanne sits on the edge of the seesaw, it rotates and hits the floor. Joanne's weight is exerted on the edge of the seesaw. The weight is not directly above the pivot, therefore causing the seesaw to rotate. Over here, when Joanne sits at the center of the seesaw where the pivot is, there would be no turning effect. Joanne's weight is exerted right above the pivot, hence no turning effect.
So the pivot causes the turning effect.
No, it's not the pivot that causes the turning effect. Rather, it is your weight from the pivot that causes the turning effect. When there is a force a certain distance away from the pivot, it will cause a turning effect. However, when the force is directly above the pivot, then there will be no turning effect. We call this turning effect the moment of a force. Take note of this term, as I will check if you know what it means in the exams.
It's in the exams? Tell me more about it.
Sure.